object storage, and the block storage was basically a very simple storage type, which is used in certain scenarios such as enterprise databases, and some of the advantages of that was the direct access to the data. So you have a direct access to the data, and but as well, when we talk about these advantages, we've mentioned the high cost and poor scalability. That means that we can't have this type of storage in a very big enterprise. Okay, so this and the connection that is used, the protocol that is used for the connection for this one, we had the HCIA and the fiber channel FC. So when we talk about that, and then we mention the file storage, which was a type of storage that sits on the block storage, but it mostly works with folders and files as a structure. So this is easy to manage because of the type of the way that the files are kept in terms of folders and files. So this will be easy, and the type of connection that is used, the protocol, we have the NFS and the CIFS. And the third one was the object storage. So the object storage, which also sits on the block storage, but the object storage will have an object system where every object will have like a key data, metadata, and user-defined metadata. Though that means that we have every element. So this is an example of what you have. If you have a picture, you save it on your Google Drive. That picture is saved as an object. So the object will come with a key. That's why you can give me a link, and I can be able to access your file. Okay, and then we spoke about a technology called the RAID technology, which is just a technology where we're going to actually combine multiple disks, and we combine multiple disks into one logical disk. What does it mean? It means we take multiple physical disks, we connect them, and we let the computer read them as if it was one disk. All right, so this was a good method for more security and for a better performance of the whole system. And then we've seen that the way this method is applied can be applied in different ways. So basically, as the disk are placed, we can have method that we call the mirroring. That means that the data in one disk is the same as the next disk. Just for in case we have a problem, we have a backup, So we've mentioned different type of RAID. So we've mentioned from RAID 0 to RAID 6. We have a RAID 10, which is combining a RAID 0 and the RAID 1. Okay. We spoke about RAID data distribution, where we can actually strip one disk. So these are the level. So okay, in terms of data protections, we've mentioned how we've used a method of the parity check. So the parity check, where we use the exclusive OR method, logical method. So where we have an information which is positive in disk 1 and positive in disk 2, that will be a 0. So we only have a 1 if they are different. Okay. So today we're going to talk about RAID OTSPE and reconstruction. So if a disk is faulty, right? So in the case where we have a problem. Sorry, is anyone asking something? Okay, guys, unless you are talking to the class, please keep your computer muted. All right, so if a disk that you are using is faulty, right? So if there's a problem with the disk, So basically, a disk or a group of disks are just faulty, right? We have a functional backup. So basically, remember when we said the method of mirroring, where we have in our RAID, we have multiple disks. So we have here, for example, here we have the disk 1, disk 2, disk 3. But now, OutSpay is basically, I can call it a standby disk, which will automatically replace a disk that will fail. So this is a OutSpay. So this is a disk. In case we have a disk that fell, the OutSpay disk is going to replace that disk, the faulty disk. So when we talk about RAID OutSpay and reconstruction, so basically we have a disk. A HotSpay is a standby disk that will automatically replace a failed disk, right? To maintain the data, to prevent all the data loss. Okay, so basically you understand the purpose is just to ensure that there's a continuous RAID system without manual intervention. Okay, so you have the SPAY disk, which is shared by the RAID group in the system. And then the SPAY disk is used only by specific RAID group in the system. So we have this specific group of disk here. We have the HotSpay disk right here. So in case there's a problem, the HotSpay will replace this disk that is faulty, right? So we had the 1, 2, 3. So disk is A0, A1, A2, and if there's a problem maybe with A0, the HotSpay disk will replace that one. So as I said, it's just a standby disk, right? So these and the type of HotSpay that we have a global HotSpay and a dedicated HotSpay. So a global, what will happen with the global? So the global is shared by all RAID groups of system. That means all the disks in the system are sharing that HotSpay. So this one can replace a failed disk in any RAID group within the system. Okay, so this is basically going to be more flexible, and it's going to be sharing all the resources. But then when we have dedicated HotSpay, so this is just reserved. This one will be reserved for specific RAID group only. Okay, so in this case here, if let's say we have 100 disks, in the first case, the global, it means that any of the 100 disks that is faulty can be replaced by the HotSpay disk. But if we have a dedicated, maybe this disk can only replace the first 10 disks. All right, so that's the definition there. So so basically we have now RAID reconstruction. That means that when we talk about RAID reconstruction, what we mean is the process of rebuilding data onto the HotSpay after a disk failure. So remember, we have this disk. So now when this disk replaces that one, it needs to rebuild all the data on it. So it's gonna operate the same way that the previous one was working. So the steps will be to just detect if there's a failed disk. Obviously, we detect there's a failed disk, and the system will automatically activate the HotSpay disk. And then it's going to reconstruct the data using, remember the method we learned, the mirroring and parity. So it's going to use mirroring and parity information to basically reconstruct the HotSpay. Okay, so this is it's very important for you to understand that this is really good in terms of it's going to minimize all the downtime. That means that if there's any problem, everything automatically, we have an automatic replacement for just to ensure that there's a continued operation within the whole RAID. So anything that the system is doing. So think of, let's say, think of companies like Facebook or Instagram. So you don't want them to have an issue with a disk and the whole system is down. So they need to have this type of system where when there's a problem with the disk, we have an hot-spare disk that will replace that, and the data are rebuilt on it, and the clients may not notice what has happened. Okay, so it's also good because it's going to maintain the data safety, kind of prevents data loss while rebuilding the data on the disk. Okay, so just to summarize that, you need to understand a hot spare is just the pre-allocated backup disk. Okay, and reconstruction, when we talk about reconstruction, what we mean is the process of restoring all the lost data onto the new disk, right? All right. Any questions? Any questions on this, guys? Any questions? Okay, so these are just type of common RAID levels. So these are some of the levels. We have certain disk here, and then you have your logical disk there. So remember here, so we have this physical disk.
Sir.
Yes.
Sir, I have a question.
All right.
So it's Samkelo, can you please go first?
Oh, okay. Thanks. Good evening, sir. Okay, so my question is based on the hot spare RAID disk, right? So let's say one disk goes down. Is the data already backed up on the hot spare disk for it to actually keep the system?
All right. So
yes,
redundant. Yeah, we spoke about method that I use when you're building that. We have the parity. So you see here we have a parity disk. That's for security, and then we have the other one, the mirroring. So mirroring means that when we have this group of disk here, let me go here so you can see properly. Let me go next here. Yeah, you see here. Sorry. All right. Let's say you are using this, the RAID 0 here. So if you are using this, for example, you have here. So in this system, so this is what you have as your logical disk. This is what you have, right? So now, in this disk here, you think you have 4 disks, but actually, if you're using a mirroring system, maybe you only have 2. So the other 2 are a mirror of the previous one. So they have the same data. So they are the copies of the other one, kind of a backup. So now that hot spare, you see in this case, you need 4 disks because the 2 others, the 2 extra disks are disks that are mirrors of the other one. Now, if there is a problem with one of this, you don't want to be stuck with only one disk this side. That's what the hot spare does. It replaces the one that is faulty, and the data from this mirroring will be rebuilt on that. Do you now understand?
Okay, yeah, that clarifies it.
Yeah. So basically, in this case, for example, we had a problem with A0. So A0 have another disk which has the same data for A0 as A0. So when this hot spare disk replace this one, those data are rebuilt on this disk. All right. What was the next question, guys? There was another question. There was another question someone else wanted to ask. I'm not too sure who was that.
Sir.
Okay.
Yeah. Can a hot spare be shared among multiple RAID arrays?
It's depend. it's gonna depend on the structure that was built for this disk, because you see here we have OTSPay that are global, and then we have those that are dedicated. So if it's a global one, the structure allows that OTSPay to be global. It means that OTSPay can replace any disk. But if it's dedicated, then it can only replace the disk that it was dedicated to replace. That's the thing, because the whole process of the OTSPay, what it does, it's first we have to detect a failed disk. If we replace the failed disk, if it's allowed to replace it, then we're going to activate the OTSPay and then reconstruct the data using mirroring or parity information. So that's what will happen. So the reconstruction here, like in this case, we have a problem with A0. So the reconstruction of the new OTSPay disk will have to happen with information from the parity disk. So the parity disk, the parity information and mirroring information are the ones that are going to help reconstruct the OTSPay. So saying that data can be shared amongst will depend on if it's a global method or a dedicated method that was used. All right. All right, guys. So some working principle of RAID 6. So when we talk about RAID 6 DP, what we mean by that is RAID 6 double parity, right? So these are just a working principle here. So the double parity, so basically in addition to the horizontal XOR parity used in RAID 4, right? So remember when we said the XOR, it means we take two disks and then we see the information, the yes. So for you to have a yes in the as an output, we need to have a yes and a no, or a true and a false. Then you have a true. So they need to be different. So different input will give you a positive output. All right. So in this case, in addition to the horizontal XOR parity disk used in RAID 4, we're going to add another disk to store diagonal XOR parity. So what does it mean? It means the RAID 6 is just an extension of RAID 5, if we can call that, or an extension of RAID 5. But instead of one parity block, what we're going to do is going to maintain two independent parity blocks. So we have one that is horizontal and one that is diagonal. These allow the RAID 6 to just tolerate some similar disk failure. So this method is just in the case where we have two disks that will fail at the same time. So on the horizontal, let's say we have a P0 and P3 on the horizontal parity disk. So where we have the parity information. So this is here. We have the horizontal parity disk. We have a P0 and a P3. What is P3? P3 is here. So if we take, let's say, in the horizontal, we have a P0 and a P3. We have that information in the horizontal data. And that information will be taken on all the disk. So whenever we have a problem anyway, this data will be taken there. Okay. And then we have, in the diagonal parity, we have DP0 and DP3 here in the diagonal parity that will represent the diagonal parity data information. Okay. All right. So now in this case, we can have either one disk. So we have this disk and this disk. So we have ways of extending to these four here. So we extend them to 6, to RAID 6. That's why we call it a RAID 6 double parity. So in this case, we have two backup. Think of it as two backup instead of having one. So and this is like the structure that already worked when we talk about the RAID 5, which we spoke about last week. Okay, so that's the thing. So a P0 now will be here. Will have a D0, D1, D2, and D3. So it's going to act on this disk. Okay, so that's how we're going to calculate the horizontal parity, and then the diagonal parity. Okay, so the diagonal parity will be calculating along the diagonal across data blocks. So we're going to have the diagonal parity. So for example, we have DP0 here, which will be D0, D5, okay, D10, and D15. So this will be the diagonal parity. So you understand, in this case, to get the DP0 here, trying to see where's the pen so I can. Okay, so horizontal parity. In the horizontal parity, so we're going to have this. I don't know why it's not allowing me to draw there. Okay, let me take the highlighter. So the horizontal parity will take that to give us the P0. But now the diagonal parity, like this DP0 here, will work with this stripe of the disk. Guys, remember here we said when you have a disk, we mentioned that we can stripe the disk. So here we have stripe 0, stripe 1, stripe 2, stripe 3. So with the diagonal parity, we're going to take D0, so we're going in the diagonal like this. So that will give us the DP0. Okay, so we need to remember that data is striped across multiple disks. So we have all these disks where we've already striped them. So for each stripe, we're going to have, for each stripe, or we can say row parity, you need to understand that the P, like the P0 here, will protect against one disk failure. So the P0 here will protect against this disk failures here. And then we have the DP, the diagonal parity, which will provide the second layer of protection. Okay, so in case we have maybe a disk here or one stripe here and there, so diagonally, so they're going to work together like that. So one of the advantage with this system is that we can have two disk failure without any data loss, which is different from only using one recovery system. So you need to understand, just to summarize, a RAID 6 double parity will use an horizontal XOR parity and a diagonal XOR parity. Okay, so this will work together, and this dual parity system will just enable the data recovery even if we have two disks that fail simultaneously. Okay, so then you need to understand it because of this that many enterprises will prefer to use the RAID 6 structure. All right, guys, I think that will be all for today. Our time is up, and tomorrow is Wednesday. So on Thursday, we're going to talk more about this and go into more details for a better understanding. And tomorrow we're not going to be having a class because it's a public holiday. Okay. Any questions? In the meantime,